Today we're going to give you a very brief introduction on our polynomials unit. This unit covers a lot of vocabulary, so I recommend taking a highlighter, and every time you see a vocabulary word, you highlight it so you can access it again at a later time. So the first thing we want to talk about today is to review what is a term. So a term can be one of four things. A term can be a number, it can be a variable, it can be a product, or it can be a quotient. So a term is one of these four things. A term can be a number, which is like the number 5. A term can be just a variable, we'll say x. A term can be a product of a number and a variable, so if I were to make that 5x. And a quotient can also be a term, which would just be like 5 over x. Okay? We talked about terms in the beginning of the school year when we were combining like terms. So remember, whenever we combined like terms, we would draw slashes in front of our plus or minus signs because that's what distinguishes a term. So this star right here is to represent, to remember terms are between plus or minus signs. So if I look at these examples below, I'm going to draw my slashes to help my brain. If you don't need to draw your slashes anymore, that's fine. But notice I have 1, 2, 3, 4 terms. So this would be a 4 terms. Okay. If I take the next one and I draw my slashes, I have 1, 2, 3 terms. The nice thing about drawing your slashes is it really distinguishes the types between your terms. It distinguishes the specific terms. I'm sorry. And if you look at this example, 2a would be a product, 4b would be a product, and negative 5a cubed is still a product because that's just negative 5 times a times a. So now I hope you're all sitting here wondering what is a polynomial. We have some key vocabulary words to discuss. So a monomial is a one-term expression. So a monomial, mono stands for one. It's a one-term expression. So example 5 would be a monomial. Or another example is 2xy. Any problem that doesn't have a plus or minus sign, there's only one term. So it's a one-term expression, that'd be a monomial. A binomial, bi means 2, so a two-term expression. So an example to that would be 5 plus x, or I could even say x squared plus 6. I have exactly 2 terms. So you can probably take a great prediction on what a trinomial is. A trinomial is a 3-term expression. So if you wanted to give me an example of a 3-term expression, I could say 2x plus 7y plus 6. I have 3 terms. Now I couldn't say 2x plus 7x, because if I just write it real quick, plus 6, because I could technically combine those to make 9x, and then it really wouldn't be a trinomial, it would really be a binomial. So we always want to use the different variables when we're talking about the number of terms. So then a polynomial is, which is what this whole next unit is, a polynomial is 4 or more terms. So if you want to give me an example, I could do x squared plus 6y plus 2x minus 7. I have 1, 2, 3, 4 terms. And if I want to go back and look at these examples on the top of my screen here, I have 4 terms, so that I would classify as a polynomial. If I look at the second example, I have 3 terms, which that's classified as a trinomial. Okay? So we still have more vocabulary. That's the whole part of this first unit. So let's keep going. Degree of a monomial. So a degree of a monomial is the sum of the exponents of a variable. The sum of the exponents of a variable. So a degree is just a fancy way to categorize exponents. So it's taking the exponents on the variable and it's saying, okay, what power does it have? It's kind of like having a building, and in a building, you have different floors on your building. And on the first floor, it's degree 1, on the second floor, it's degree 2, and on the third floor, it's degree 3. Which means everybody who only has an exponent of 1 is on the first floor, and everybody who has an exponent of 2 is on the second floor, and so on and so forth. But degrees are only found on the variables, not on the coefficients or the constants. So if I look at this first example, 6x, I look at my variable x, and x's exponent is 1, so this has a degree of 1. If I look on B, 4y cubed, y is my variable, y's exponent is 3, so this has a degree of 3. So if I go back to problem A, since it has a degree of 1, it would live on the first floor of my building. And because this had a degree of 3, 4y cubed would live on the third floor of my building. It's just telling you the power. It's telling you the degree. If I look at C, notice on C I have 2 variables. So when you have 2 variables, you have to take the sum of the exponents. So x's exponent is 2. And y's exponent is 3, and 2 plus 3 is 5, so this lives on a degree 5 floor. Okay? And if you take a look at the next one, notice the next one doesn't have a variable. So since it doesn't have a variable, its degree is just 0. So that's the degree of specific monomials. The degree of the polynomial of a whole algebraic expression would be the biggest degree of each monomial. Monomial is one term, so I'm going to look for the degree of each monomial, and the biggest one wins for them all. So if I look at this example and I draw my slashes, my first term has a degree of 4 because x's exponent is 4. My second term has a degree of 3. My third term has a degree of 1 because x doesn't have an exponent. And 1 has a degree of 0 because constants don't have degrees, only the variables. So out of 4, 3, 1, and 0, what's the biggest number? 4. So my degree would be 4. So if I go back to my building, it would now be living on the fourth floor. So now let's go ahead and look at the next one. Draw my slashes if that helps you. This has a degree of 3. This has a degree of 3. This has a degree of 2. This has a degree of 1. Negative 6 has a degree of 0 because it has no variable. So the degree of the whole polynomial is 3 because the biggest number is 3. The biggest number was 4. So now if I draw my slashes and I look at the last one, x squared y, I got to put my variables exponents together to determine the degree. So 2 and 1 would be 3. Here that would be 2. Here that would be 1. And my last term would be 0 because it doesn't have a coefficient. It doesn't have a variable. So the degree of this polynomial is biggest number 3. Okay? If I go ahead and I keep going, let's now quickly talk about standard form. Standard form just means biggest degree to smallest degree. Now, we've talked in the past that order doesn't matter. Typically, algebraic expressions are in standard form. We've been learning about polynomials our whole year. We just haven't actually ever classified them as a polynomial. But a polynomial is just, when I want it in standard form, I just want it biggest degree to smallest degree. And remember, degrees correspond to the exponents, so it's really biggest exponent to no exponent. So if I look at my terms, my biggest exponent is 2x squared, so that's going to come first. My next one is 3x, so it's positive. And 4 is negative, and it has no exponent. It has a degree of 0, and so that's put in standard form. So go ahead and pause this video, and I want you to try the last one on your own. Hopefully you got this answer. 6y cubed is the biggest, negative 2y squared is next, plus 5y plus 5. Okay? When you're ready, go ahead and flip your paper. We're now going to quickly talk about how we can perform basic operations with a polynomial. I can add, subtract, multiply, and divide a polynomial, no problem. We love adding and subtracting. They're super duper easy. Adding polynomials, all I do is combine like terms. We've been doing this since August, so you're experts at this. All I'm doing with adding polynomials is combining like terms. I can only add the terms that are alike. I can't add x with y. I can't add x squared with x because they are not alike. Remember, we talked about it being like a McDonald's. You can't combine a small French fry with a large French fry. It doesn't work that way. So if I go ahead and I look at number 1, notice I have parentheses around my two polynomials. This here is 3 terms, that's a trinomial, plus a trinomial. Notice, since it's positive, I really only have an invisible 1 hiding in front of my parentheses. And if I were to distribute positive 1, isn't that just the same thing? So I can technically rewrite my sentence without the parentheses. You're going to get good where you don't have to do this, so we'll start it in the beginning. And now all I do is draw my slashes and combine like terms. 4x squared I can combine with 2x squared, and I get 6x squared. 6x I can combine with negative 9x, and I get negative 3x. 7 and 1 add together to make 8, and I'm done. Some of you might be asking, well, why am I not adding the exponents? Why is x squared and x squared not make x to the 4th? Because remember, with the law of exponents, the only time I'm allowed to add exponents together is when I'm multiplying. When I'm not multiplying, I can't add exponents. So that's the famous most mistake is x plus x versus x times x. X plus x is 2x, but x times x is x squared. Because these have an invisible 1, and when multiplication is between your bases, you can add your exponents. Because I was combining like terms on this problem below, I can't add exponents because I'm adding, so I just would combine like terms. If I go down and look at number 2, I know I'm adding a binomial plus a binomial because I have a plus sign in the middle. So I'm just going to get rid of, I'm adding, those parentheses are basically useless. So I'm going to go ahead and get rid of them. And then I'm going to draw my slashes. 12m squared I can combine with 8m squared, and that gets 20m squared. 4 I can combine with 5, and I'm going to get 9. Okay, so hopefully you're going, I hope the unit stays this easy, which would be wonderful. I want you to go ahead and I want you to try 3 and 4 on your own, and we'll go over it next class. I want to real quickly talk about subtracting polynomials. Subtracting polynomials is almost as easy as adding polynomials. There's just one tiny extra step. Subtracting polynomials, if you come down and you preview this problem, I have a negative here. And remember, whenever there's nothing in between the negative and the parentheses, there's an invisible 1. So I have to distribute that negative 1 to everybody behind it. So when I'm subtracting polynomials, I have to distribute negative 1 to second parentheses, and then I'm going to combine like terms. So if I distribute negative 1, I'm going to get negative 4x cubed and negative 2x squared and positive 7x and negative 3. And then I'm going to copy down the first parenthesis. And now I'm just going to draw my slashes and combine them. So 2x cubed I can combine with, oops, that negative I hid, it was in the back there. I can't even read my own writing. That's a 1. All right, so 2 and negative 4, that makes negative 2x cubed. Cross those out. 6x squared and negative 2x squared, that makes 4x squared. Negative 7x and 7x, that makes 0, so they're just going to cancel out. I don't need to write them. And 1 and negative 3 make negative 2. And I'm done. So adding, all I do is combine like terms. Subtracting, I have one extra step where I have to first distribute the negative 1, and then I combine like terms. So I want you to go ahead and I want you to finish the page, and then we'll go over it next class.